All right, good morning. So we are going to continue speaking about trig identities and how to get through that. I'm going to take you with a little guide through the homework with us because, yeah, those are not, they can be a little confusing. Okay, so I apologize for that. So let me go ahead and share my screen here. Okay. Let you know again, like we went through this was the best option. Okay. So what they were asking us is like find the least common denominator between like AB and A. All right. So what they want to do is like say something like what is the least common denominator? Right. Like 1/3 and 4. Okay. So wait, 4 is a fraction, right? What would I in order to do to make common denominators here? We just multiply 3 by 3. This would be 1 by 1. We don't really count the 1, so our least common denominator is going to be 3. All right. Oh, there was a problem with this assignment. Dang it. Serves me right. Problem with this too. Let me pause this. Okay, unpause. Okay, so in this case, I've got like 1 over b, 1 over a. What's the least common denominator is ab. We're just going to assume that these are relatively prime to each other. Okay, so that should be okay for that. Okay, 1 over b. Okay, I'm not really quite sure what they want here. 1 over b. Okay. No. What do they want? How about a, b over b? All right. They don't want that either. I tried that, they didn't like it. Okay. So when you're going through this, you're having a tough time. Really? Understand, I'm having a tough time with this too. Okay, but now I've got this. They said 1 over b is equal to 1 over b times a over a. Okay, so here, how about we say this is b over ab. Okay, let's see if that does it. But they are really, really picky. And notice I put what a over ab. It says no, you've got to multiply it on the right, not on the left. Okay, when you get to something called linear algebra, that's actually an important thing. It's left multiplication and right multiplication, but that's we're dealing with different things. We're not dealing with just numbers anymore. Okay, so LCD here is going to be, they don't like it if I type it, sine x, cosine x. And then sine x equals, so you're not going to fool me again, this is going to be fraction, and we've got cosine x over sine x cosine x. I'll bet that's what they want. Okay, and 1 over cosine x is going to be sine x over, oops, no, wrong one. No. Oh, no. I have to do it this way. Fine, sine x over cosine x sine x. Okay, so all we're trying to do here is force you to make the problem, make this expression equal to something that they think is going to be useful to you later on. And this is a useful skill to have. Okay, I wish it wasn't quite so picky. Okay, but there we are. All right. So what are we doing? This common denominator is going to be parentheses. Could I do parentheses? 1 plus a b. Okay, because that's what I would do to make a common denominator for this one. All right, 1 plus a. Okay, not going to fool me again here. So if, oh, we're making the common denominator. So that's going to be b rather, over 1 plus a, b. Right? And an AB, so they want the other one here. So this is going to be a 1 plus a over b plus a. Okay, so this one I kind of get. I'll watch you tell me I'm wrong. Okay, and then they're going to have us do it with the trig function. So you see what they're doing is like they're giving us like the generic, here's like A's and B's and do it with that. And then they're just trying to show us like, hey, look, it works for, it works for fraction, it works for this stuff too. So I want to get a common denominator here. LCD is going to be parentheses 1 plus sine x and then cosine x. All right. So we're just trying to mimic what we just did with the A's and B's with this stuff here. Okay. So 1 over sine x is equal to fraction cosine x over parentheses. You'll notice they don't put the parentheses in here. Like that's something you got to type in on your keyboard. Okay, cosine x. All right. So I understand, this is what we're getting for, how frustrating it can be. Let's see here. We looked at this and we are going to have a sine x, because that's the original sine x. But what did we multiply by? We multiplied by 1 plus sine x. Oh, no, 1 plus sine. And that's what we wanted. Sine x over cosine x, and then multiplying on the right by 1 plus sine x. Okay. So I know it's a little frustrating, but this is what they have us do. Okay. I'm going to go ahead and skip forward a little bit. I think you guys are going to be okay with multiply. What do you want me to do? You don't have anything else. Well, let's guess. This is parentheses. Oh, they don't like the parentheses. What am I supposed to multiply here? Okay, again, I just want you to realize like what we're doing with, oh, they just want us to multiply this out. Okay, so this is going to be a squared minus 2ab plus b squared. Okay, that's all they want. But if you're ever looking at this, like what did they want exactly? So this is going to be sine squared of x minus 2 sine x tangent x plus tangent squared x. Right. So again, all we're doing is like, we could do it with algebraic things. We could do it with x's and a's and b's. You could also do it with sines and cosines and such. Okay, that's all they're trying to show you here. Okay, before they push you out of the nest and say, good luck. Okay, factory expression. A minus b, a plus b. All right. All of this would be just fine. I would not lose, well, I would lose some sleep about asking you these questions because they are a little on the beginning side. We want sine x plus cosine x. Difference of squares, that's all they want. All right. You can see a lot of these, the fact that there are 18 of these things, like that sucks, but this is a good one. but a lot of them are they're like 1-2 shot type of a problem. Okay, you should not have problems with this. All right, this one, guess what kind of problems I like to give you. This is 5a squared plus 12ab minus 9b squared, okay? AC method. So first number times last number is negative 45, okay? Can you think of two numbers whose difference is 12, right? The minus is 12, but we add up to 45, okay? What is 45? 5 times 3 times 3, right? So we have 1 and 45. We have 3 and wait, that's a 12, right? We have 5 and 9. That's it. Okay. So if we do a 5a squared plus 15ab minus 3ab, right? 15 and 3, positive 12. So we want to make 15 the positive and 3 the negative. Okay, minus 9b squared. Did it matter which way I put them down? No. Notice this is a 15, that's a 5. This is a 3, that's a 9. So I do try to group like with like. I try to say, well, let me see if I can't do, group things with common factors in them together. That's the only decision I've made. 5a. Okay, what's next? We have 5a plus the pull out of 3, right? Pull out of 5 rather. We have 3b. If I multiply it back in, we're going to get this back, okay? Minus, okay, 3b, okay? And if I pull out a 3b, what do I have? We have a, all the minuses are out here, so we took this minus sign here, so this is a plus. And we pull it out of 3b here, so 3 plus 3b, okay? Both of those are a plus 3b, parentheses, and then we have 5a minus 3b, okay? So pay attention to these. I like these kinds of problems because I know you don't get enough chances to practice factoring. So this just forces you to come up with like, well, we're going to have to factor some more. So let's practice. Okay. Oh, I didn't pull my little thing here. This was what? This was a plus 3b. A plus 3b, parentheses. And then we have 5a minus 3b. 5a minus 3b. Great. Hey, would you look at that? They put sines and cosines in here instead. Okay, who would have guessed? So this is exactly the same structure, right? With 5, one thing squared plus 12, thing 1 times thing 2 minus 9 thing 2 squared. Okay, so we're just going to write that down because it's exactly the same structure as this one had. So it's going to be sine x, okay, plus 3 cosine x, that's our b. Parentheses, we have 5 sine x minus 3 cosine x. All right, that's all they want us to do with that. All right. There should be a minus in here somewhere, shouldn't there? That makes me a little bit happier. There we go. Just double checking to make sure I got the same structure here. So thing plus 3 thing 2, 5 thing 1 minus 3 thing 2. All right, that's happy. All right, it's not too bad. Simplify the expression, write the final form with no fractions. Okay. So yeah, they didn't give us the right-hand side, so good. Okay, because you're not supposed to be using one anyway. But all they want to do is simplify this thing. So we have sine x, secant x times tangent x. All right, so this is equal to sine x times 1 over secant x times 1 over tangent x. Okay, because we can separate fractions like that, right? 3/4 is the same as 3 times 1/4. That's what we did. So what's 1 over secant? 1 over secant, right, is cosine, right? And what's 1 over tangent? Oh, that's cotangent. I don't think we're done yet, because I think we could break down the cotangent. So we have sine x, cosine x, and what's cosine? Cosine is, or cotangent rather, is cosine x over sine x. That will cancel, and we'll have cosine squared x. Okay, so we're going to say cosine, squared x. All right. Okay. And again, crossing my fingers every time I do this, because I guess is that the form they wanted? I don't know. I hope so, but I can't be sure. Okay. Cosine squared x plus 1 over sine squared x plus 1 is equal to what? Okay, so let's see here. Why don't we do something clever, like turn our 1 into a sine squared over cosine, or sine squared over sine squared. So we'll say cosine squared x plus 1 over sine squared x plus sine squared x over sine squared x. Okay, when in doubt, think, well, we got a fraction, we got a plus sign, let's go ahead and add them. Okay, so now that we have, not that pen, now that we have what's going on here, we can say this is cosine squared x plus 1 plus sine squared x all over sine squared x. Don't do this, right? And we're going to rearrange. So I'm going to say this is sine squared x plus cosine squared x plus 1 over sine squared x. Do you know an expression that lets us do something with sine squared and cosine squared? That's 1. Okay, so we end up with 2 over sine squared x. And now we have a mystery, because it's both of those things. How do they want it? Write the final form with no fractions. Okay, so they actually want us to write 2 cosecant squared. 2 cosecant squared x. Okay, so, hooray, we got it. But honestly, you know, they don't give you very much direction with this, so I can understand where you might look at this and say, yeah, that's not happening. Okay, so for this one, we have 10 sine theta minus 10 cosecant theta all over cosecant theta. Allow me to do this. Okay, you can break up the fraction on the top. So this is 10 sine theta times 1 over cosecant theta minus 10 cosecant theta times 1 over cosecant theta. Okay, just broke up the fraction, so I've got the first fraction, right, minus the second fraction, and instead of writing it as a fraction, I wrote it as 3 over 4 is equal to 3 times 1 over 4. Okay, that's all I did. Okay, so this is going to be 10 sine theta. What's 1 over cosine theta, or cosecant rather? 1 over cosecant theta is sine theta. That's from the reciprocal rule. Minus 10, and here we have cosecant theta over cosecant theta. This is going to cancel. Okay, so we're going to have 10 sine squared theta minus 10. Now, I'm not really sure what they want after that. They might want that, they might want this. Notice they've been really picky about what we wanted to do. Final form their fraction. I'm tempted to want to say this is 10. Oh, I'm not tempted because they're not going to let me have parentheses. So this is 10 sine squared theta minus 10. I don't want to know. Oh, they won't let me do it. Check our answers. Oh, fill in the empty boxes. 10. No, I like the bottom one being a 1. Sine over cosecant, sine times cosecant will be 1, but sine over cosecant is going to be sine squared. Okay. So I don't know exactly what they want us to have here. I'm just going to recheck it twice to see what happens. Oh, okay, that's what they wanted. Okay, here's what they did. I should have guessed. Sine squared theta minus 1. Now, recall, sine squared plus cosine squared is equal to 1. So cosine squared is equal to 1 minus sine squared. Now, if I do a negative cosine squared, that's equal to negative 1 plus sine squared, or sine squared minus 1 is equal to negative cosine squared minus 1. All right, I should have been prescient enough to to anticipate that's what they were going to do, but I was not. Okay, so understand that yes, sometimes what they're looking for is not always the value that you're going to be getting. Okay, but I know how to get that now. If I tried another one, you're going to see it's going to be a very similar problem, and I'll know what I'm supposed to do with this. Okay, so this would be 1 minus cosine squared, and then I would know to change it from the Pythagorean identity. Okay, so that's what they're going to have us do. Okay, simplify the fraction with no. Okay, in the homework in the book, like a little bit later on, you're going to get something where it says verify this side equals that side. Okay, that's what we're talking. That's the kind of problem you're going to encounter. I am not going to give you something like this one on a quiz and say, guess what I wanted. Okay, no, that's not fair. That's not right. How are you supposed to know? So you're going to get something. I think we're going to see them a little bit later on. Verify the equation as an identity. This is the kind of problem you're going to be seeing more. Okay, where I tell you, you can start with this and with this one. Or, because I'm not going to tell you which side you have to start on, you could start with the 2 cosecant theta, or 2 cosecant squared alpha is equal to this side. It doesn't matter which side you start on, as long as you stick with that side. Now, it's going to happen that you are going to start with a side, and you're going to end up in, I have no idea what to do from that. You scratch that out, and you start with the other side. Okay, that's what you do. So what we're doing here, I said, guess. Like, okay, let's see if we can guess. So this is going to be sine x secant squared x minus 4 sine x. This is sine x secant x plus 2 sine x. Let's see here. Normally I just want to say no, but okay, let's see if we can do it. Okay. Well, I'm noticing that a sine is common to most about everything here. So what if I pull a sine x out of this, and we'll have our secant squared x. No guarantees that we're going in the right direction here, okay? And then we have a sine x, and we have a secant x plus 2, okay? The 2 sine x's, those will cancel. So we'll have our secant squared x minus 4 over secant x minus 2. This here, this is a difference of squares, isn't it? So this is going to be secant x minus 2, secant x plus 2, all over secant x minus 2. Cancel that, and I will bet this is the answer they want. Okay, so we're going to have secant x plus 2. Okay, so we have secant x plus 2. Okay, it's not a phase shift, it's a vertical shift. They didn't like that at all. Of course they didn't. Let's see. No final form with no fractions. That's going to make it a fraction. I don't want to. My next thought would be secant is 1 over cosine plus 2. But I really don't want to do that because the only thing I could really do is say, let's say something like that. We could say something like 1 over cosine x plus 2 cosine x, which is 1 plus 2 cosine x, all over cosine x, and then say 1 plus 2 cosine x. Cosine x is really 1 over, or 1 over cosine is really 1 over secant, is really secant. So maybe they want this. Okay, so this was what? 1 plus 2 cosine x, 2 cosine x. I'm not allowed to have parentheses. It won't let me do it. Okay, so obviously that's not the right way. Okay, how about 2 plus secant x? They got mad at me for writing it in the wrong order once. Maybe they'll get mad again. All right, we're just gonna, I give up. Did I not? I wrote the problem down wrong. See right here. Instead of a plus, I put a minus. So that's why I got that one wrong. That's okay. Again, if I did it again, it wouldn't be that bad. Okay. Okay, and okay. Let's be careful to write the problem down correctly this time. So we have tangent squared x minus 14 tangent x plus 49. And this is sine x tangent x, oops, no parentheses, just tangent x. Sine x tangent x minus 7 sine x. Okay. So what I'm going to do is I'm going to pull sine x out of the bottom because that seems to be the obvious thing. We have tangent of x minus 7. Okay. This is suspicious because we've got a perfect square, I've got a perfect square, and 7 plus 7 is 14. So let's do a guess and check here. Let's do a tangent x minus 7, tangent x minus 7. Normally I'd write the square, but you see what's going to happen soon here, right? So if I multiply this out, right, that's going to be tangent squared minus 7 is minus 14 plus 49. We double checked to make sure that if we multiply back, we get this thing back. We'll pull out tangent x minus 7, and we'll have our tangent x minus 7 over sine x. What are we supposed to do? What are the instructions? No fractions. I don't think they're going to want us to write something down like this. They might, though. Okay. So we'll keep this one as a maybe if my other problem doesn't turn out so well. But this is sine x over cosine x minus 7 times 1 over sine x, right? I'm not liking this either. That maybe is looking stronger. So we have sine x minus 7 cosine x all over cosine x times 1 over sine x. I am not saying this as a no fraction sort of a thing, so I'm going to go put this in the maybe pile, but now I'm coming back to it. I like sine x minus 7 times cosecant x. Do we get parentheses? We do not get a parentheses. All right, we don't get a parentheses. So we're looking back at this again. Well, what if we pull this one in here? We say this is all right. So let's try this. We have a sine x over, I think I'm going to get back to the other one. All right. So this is going to be a 1 over cosine x minus 7 over sine x, which is going to be a secant x minus 7 cosecant x. Let's try that. Okay, so this is going to be it doesn't require any parentheses. So we need a secant x, okay, minus a 7 cosecant x. How about that? Okay. By the way, you're going to have to do some trial and error on this one. I'm really sorry that that's the way it is. Okay. But they don't give you a lot of direction. You kind of have to infer what's going on with everything else. Okay, I'm going to stop this so we can do the rest of them. I think we can get through. I might skip a few of these and start with the identities. That's 13 to 18. Verify. Yeah, so next lecture, I'm going to do our next video. We're probably going to do a 13 through 18 kind of a thing. And, you know, I know these are painful because they don't tell you. Okay, I do. I know. I had trouble with them too. Okay. So if you have to try them a couple of times, like I get it. If you lose patience with it, I also get it. So make sure you've done at least 13 to 18. Okay, make sure you know how to do those real good. I would supplement all of this with our trick or treat sort of book and look at the first couple of ones in that level 1 chapter. Okay, so I'm going to go ahead and sign off, and we'll put another one up there in a moment.